Everyone has a moment they wish they could revisit. Maybe it's to fix a childhood mistake, or perhaps just to spend one more hour with a grandmother who helped shape who you are. We feel trapped, moving in only one direction. We assume that time is an absolute, universal metronome, ticking away perfectly for everyone, everywhere. But it turns out the rate at which you experience those ticks is entirely unique to you. Over a century ago, a young patent clerk realized that time is actually a physical dimension, intimately connected with space. And because it's a physical structure, it can be stretched and squeezed by gravity and speed. If you take a highly sensitive atomic clock and lift it just 1 foot off the floor, you move it further from Earth's center. The gravitational pull weakens, and that clock physically begins ticking slightly faster than the one on the ground. Your head is literally aging faster than your feet. It's a microscopic difference, but it proves that time varies depending on exactly where you stand and how fast you are moving. Our modern world actually relies on this time warp. The GPS satellites orbiting Earth travel at high speeds in lower gravity, causing their clocks to drift from ours. If engineers didn't actively correct for that exact nanosecond difference, your phone's map would be completely useless within a day. We've built machines exploiting this law. The Large Hadron Collider accelerates protons around a massive ring. Near the speed of light, their internal clocks slow down. A fraction of a second stretches into a longer period. They are traveling into the future. Scale that up to a human crew. If you boarded a spacecraft accelerated to near the speed of light and flew out towards the stars for a 10-year mission, you would only age 10 years. But when you landed back home, 1,000 years would have passed on Earth. Moving into the future is a proven mechanical reality. But this raises an obvious question. If the dimension of time is flexible enough to let us drive forward, what is stopping us from throwing the engine in reverse to reach the past? Going backward requires taking that 4-dimensional structure of spacetime and bending it so severely that it folds back onto itself, creating a closed loop. Physicists have proposed mathematical models for how this might work. One of the most famous, championed by Kip Thorne, is the wormhole, a theoretical tunnel through a higher dimension connecting 2 different locations or even 2 different eras. But the physics demand a steep price. To keep a wormhole from collapsing and crushing a traveler, you would need to prop it open with massive amounts of negative energy, a rare anti-gravitational force that pushes space apart instead of pulling it together. Another model relies on cosmic strings. These are hypothetical, unimaginably dense threads of energy left over from the Big Bang. They might be thinner than an atom, but they contain enough mass to exert extreme gravity. This animation shows how it works. Think of the space around a cosmic string like a flat circular pizza. Because of the string's immense mass, it effectively cuts a slice out of that space and folds the remaining edges together into a cone. If you fly a ship around that conical shortcut, your path is suddenly much shorter. You could fly at normal speeds and still beat a beam of light traveling the long way around, arriving before you even left. The math holds up. But manipulating half a galaxy's worth of mass to align these strings is far beyond our reach. To find a realistic loophole, scientists have had to stop looking up at the stars and start looking down at the smallest building blocks of reality. Inside the subatomic world, the rules of normal physics break down. Particles exist in a state of probabilities, and they can become entangled. Through a phenomenon called quantum non-locality, 2 particles can instantly influence each other, even if they are separated by billions of miles. In laboratories today, researchers are testing whether this instantaneous connection can be manipulated. By sending entangled photons through miles of fiber optic cable, they are attempting to measure if a signal received at one end was actually triggered microseconds before it was sent. If we successfully send a message backward, even by a fraction of a second, we run straight into a wall of logical paradoxes. The most famous is the grandfather paradox. If you go back and stop your ancestors from meeting, you would never be born. But if you were never born, you couldn't travel back to stop them. Imagine applying this to the Titanic. What if time travelers appeared on the bridge to warn the captain about the iceberg? If the captain listens and steers the ship to safety, the disaster never happens. This diagram illustrates the quantum solution to this headache, the many worlds interpretation. It suggests that if you alter an event in the past, you don't rewrite your own history. Instead, the moment you intervene, reality splits. You create a brand new, parallel universe, where the ship survives, but your original timeline remains exactly the same. Backward time travel might not break the logical rules of the universe. It might just require fracturing reality to keep cause and effect intact. The physical barriers keeping us out of the past are immense. We cannot harvest negative energy, we cannot herd cosmic strings, and we certainly cannot wrangle subatomic quantum states into a passenger vehicle. But there is another door. Our best chance of walking through history won't come from a spacecraft. It will come from software. Computing power is compounding at a staggering rate. Eventually, supercomputers will possess the processing capability to generate complete, atom-by-atom simulations of historical eras. These virtual environments will be entirely indistinguishable from physical reality. You could step into a rendering of the distant past, seeing the world exactly as it was, and interact with it in real time. It wouldn't alter the true historical record, but it would let you experience it firsthand. For now, our physical bodies are locked into a one-way trip forward. We can't rewind the clock to erase our failures or undo our grief. That stubborn flow of time forces us to learn from our mistakes, and it's exactly what makes every moment of the human journey so valuable.